Hey, I am Marilyn Manson without the makeup. No, you already know it. I'm Javi Moreno, and today we are going to take a look at how we can create a highly available architecture deployed on AWS. And to show you an introduction to this subject, take a look at this beauty. This is an schema of the networking system that we are going to deploy. Do you remember there is a VPC, which is basically the network that we are going to create with an internet gateway that provides connectivity to the internet thanks to this route table that will help each subnet that we will create inside the VPC to communicate between to allow the instance deploy on these subnets to communicate between them and to connect to the exterior through the internet gateway. Do you remember that a subnet is attached to an availability zone? An availability zone was a data center, so that way, if you deploy your infrastructure between subnet A and B, and you create those subnets on different availability zones, you will be resilient to local disaster like a fire or flooding. Okay, let me now show you how can we deploy other kind of resources inside this network system. We will need, of course, EC2 instance. You can see those instances here and here, and we are going to deploy those virtual machines using auto-scaling groups. This yellow line represents an auto-scaling group that will be able to automatically create the EC2 instances on both subnets and to take care of them. If the instances don't pass the health check of the auto-scaling group, they are going to be automatically terminated and a new instance will take its place. The instances are going to download our Pokemon application, and that application, if you remember it correctly, uses port 8080 to publish its service. So here you will see how we are going to set the security group of these instances to allow access to port 8080. But of course, if we have more than one instance, we will need to provide to the user a single endpoint, a single way to reaching them. So we are going to create an elastic load balancer, the component that will receive the request from the outside, from internet, and we'll choose one instance to respond that request. The autoscaling group is going to connect the port 80 of its own to the port 8080 of the instances. So we will create a load balancer security group on port 80. You already know the basics of this deployment. If you have any doubt, feel free to ask them using the usual ways. And without any further preparation, let's go to the AWS consoles and let's deploy everything. But remember, you are going to provide high availability by creating two different subnets on different buildings, data centers, availability zones, and using an auto-scaling group to provide a mechanism to restart instances that are not in good shape. Okay, the elastic load balancer will be our single point of access to all the fleet of instances of virtual machines. Okay, let's open the console. Okay, here we are in the console. The first thing that we are going to do is to be sure that we are in the region that we want to use to deploy the services. I'm choosing Oregon. And then we are going to create the network by selecting here VPC and clicking on the link. And after loading the dashboard, we are going to use your VPC option on the left, and we will basically ignore the default VPC, which is this one that it is already created in your account. You don't want to use that one. We are going to create a new VPC, giving it a name, for example, Pokemon VPC, and the most important parameter of a network, which is the network range. In this case, I'm choosing 10.0.0/16, and it will press just create. Remember, all the resources deployed inside this VPC are going to start with 10.0 as the internal, the private IP of that resource. We press create, and after a few seconds, here it is, our network. Now we will need to divide this network into several subnets, so we choose subnets on the left, and again we create a new subnet. Those subnets that you have already seen here are just the subnets created by default and assigned to the default network. In this first subnet, we are going to call it public subnet A. It is created inside the Pokemon VPC network, and we are going to give it this name because on this example, against the best practices on AWS, we are going to deploy all the servers, the virtual machines, in a public subnet, a subnet that is directly connected to the internet through the internet gateway. This is not the best security option, or this is not the best option from the security point of view, but we are doing it to simplify a bit the configuration of the system. Another day we will talk about NATing and about how you can deploy the same resilient infrastructure, improving the security by reducing the exposed surface to the exterior. The subnet that we are creating is going to, for example, go from 10.0.20.0 to 10.0.20.255, as those are going to be the IPs of the resources created in this subnet. And yes, you cannot assign a .0 to a resource, and actually there are 5 different addresses that are reserved by AWS to their own resources. So more or less you are going to create 250 resources inside these addresses. All of them will start with 10.0.20 as their IP. We choose create. It will take only a few seconds, and we will proceed to create another one, taking into account that we do not want to use the same availability zone. In this case, we have created the subnet on availability zone A, so I'm going to create the other one, public B, on the availability zone B. Be sure to, I just forgot to explicitly set this parameter in the last dialog, so please be sure to choose it correctly for this one. 10.0.21/24 should be a good address range to this subnet. And now you will see how we have both subnets created on different availability zones, on B and on A. Perfect. Next step is to create an internet gateway to allow our resources to connect to the internet. We go to internet gateway, we create a new one, Pokemon internet gateway, for example, as its name, and we are going to attach it to a VPC, which will be obviously the Pokemon VPC, the previously created VPC. And the last step is to set the root table of both subnets pointing to the internet gateway that we have just created. I select subnet again, I choose public A, and take a look at root table. If you can see it right here, that we are using the AC27 root table on this subnet, and if I select the other one, you will see that we are actually using the same root table for both subnets. This is because this is the default configuration. I just need to click over there, opening a new tab to modify the root tables. Select again the 27 root table. We can go to roots and edit the root tables, adding another rule, which is going to say that basically if you arrive to this point, any destination address will be managed by this rule that will point our traffic to the internet gateway that we have created a few moments ago. I click on save. Perfect, and that's all. We have already created our VPC with two different subnets, and we have created also the internet gateway and pointed the root table used by both subnets to use it. We will start now to configure the computing resources of our system. Do you remember the schema from the beginning? We have already deployed the subnets inside the VPC with internet gateway and the root tables, and now we should start to create the different computing resources. We are going to start creating the security groups, both for the load balancer and the application servers, and then we will deploy the auto-scaling group based on launch configuration that will help us to start the EC2 instances. Okay, so now let's create the security groups. After that, we will create the load balancer. Then we will define the launch configuration of the EC2 instances. And lastly, we are going to create the auto-scaling group. Let's see if we can start. Here we are on VPC, the same place that before. We can choose security groups here because these security groups are going to reside inside our recently created VPC. We're going to create one. We will name it as the name tag is the secure, let's see, load balancer security group. And the description is the security group for load balancing port 80. And we will set Pokemon VPC as the VPC of this security group. Yes, create. And we will repeat the process again for the security group of the application server. App servers security group with a description of the security group of application server on port 8080. And yes, we will select Pokemon VPC as the place where this security group is created, and we will also press create. And now we are going to configure the details of both security groups. The load balancer security group will have, which I have selected here, will have as inbound rules will accept port 80 from anywhere. So we can just set that this is the opened port and we accept connections from any IP address from the internet. We click save to update it. Okay, perfect. And now we are going to select the other security group, the APP server security group, and we will allow to connect to them using TCP on port 8080. Do you remember the port of our application? But we are going to allow access to this port only from resources tagged with the security group of the load balancer. So only the load balancer will be able to connect to the virtual machines that will have attached this security group. I press save. Okay, and we are good to go. Now we will create our load balancer. To that, we can return to the dashboard, the general dashboard. We can choose EC2. Of course, if you already have an EC2 link anywhere in the screen, you can click on it. And we will select load balancers from the left part of the options from this main menu. And we just need to create a new load balancer. We are going to use the classic one. Remember, the load balancer will cost you more or less 15 euros per month, even if you do not use it. So be sure you delete this resource after the lab. As I have said, we have enough with the classic load balancer. It is not as sophisticated as the new version, but it is all what you need to complete this lab. We will provide a nice name to this load balancer, for example, Pokemon load balancer, and of course we will place it in our Pokemon VPC. And we will set the configuration of the load balancer to forward the port 80 of the load balancer to the port 8080 of the virtual machine instances, because the application is publishing its information on this port. Remember also that you need to add both subnets to the load balancer, so it will be deployed on both availability zone A and availability zone B. Also remember that actually a load balancer will be able to access to any EC2 instance deployed inside the VPC, no matter what is its subnet. And what you are defining here is just the subnets that will contain instances that implement the load balancer. After that, we are going to assign the security group. We select the load balancer security group, which is already configured from the previous step. We do not need to set anything on the step 3 because we are not using HTTPS. We are not going to need a certificate, but we need to set the health check of this application. Do you remember our Pokemon application is deployed on port 8080, but the resource is not named index.html, but just slash, the root of the application. Every 30 seconds, we will check this address on this port using HTTP, and we will increase a counter if it does not work, or if it is working. If we go over the number that you can see here, I have reduced the health threshold to 2, and then we will change the state of the balancing on that virtual machine. If the virtual machine does not pass the health check for 2 consecutive times, the load balancer is not going to send it traffic again. until the virtual machines comes alive for at least 2 consecutive 8080 slash requests in a row. After that, we are simply press next, and we do not have any instance so that we want or can register in the load balancer, but we will leave checked those checkboxes because we want to be able to allow an instance running the load balancer to connect to any virtual machine deployed on the VPC, no matter what is the availability zone of the virtual machine. And we do not want to cut existing connections until they have been completed, because that would provide a bad experience to our users. Next step is configure tagging. You know that tagging is basically an arbitrary metadata attached to a resource that will allow you to classify your resources, for example, for billing or to manage their life cycle. Pokemon LB is going to be the name of the load balancer. The owner is me. And the project is HA architecture. We just need to go to the last step, review and create. I'm pressing create. Okay, here we go. We already have our load balancer created. And if you take a look at the details of the load balancer, you will find its endpoint. This DNS address is what you need to use as an endpoint to the load balancer. And this is the way that your users are going to access your deployed application. Alright, and now what we are going to do is to create a launch configuration. Here on the left, in the EC2 service, you can find the launch configuration option. And remember that a launch configuration is basically a template to launch new instances, is what an autoscaling group will use to create new virtual machines. I do not have any launch configuration, so I have been redirected to the welcome to autoscaling screen, welcome screen. It is not really the best UX option probably, but it does not matter because we can press this big blue button and we will be able to create a launch configuration here. Pressing create launch configuration button. First thing we are going to do is to select the AMI, the disk, the bits of the disk that will be used to boot a new machine. We choose Amazon Linux. After that, we select the type of instance. T2 micro is enough to run our Pokemon, so we will keep this option. The next step is to give a name to the launch configuration. Pokemon launch configuration is good enough. We will activate CloudWatch detailed monitoring. This is because in another tutorial I will show you how you can monitor these instances, and detailed monitoring is more powerful than the default options, even if it will cost you a bit of money. And we click on advanced details because we really need to set the user data script that will bootstrap our instance by basically downloading the Pokemon application and starting it. Don't worry, because I have already placed the script in pastebin.com/u for users /Javi, my name. You can, computer, please zoom. Computer, thank you. You just need to go to pastebin.com Javi and look for the paste called AWS launch Pokemon user data. You just need to click over here and select the row option and take it all to the clipboard. I have just pressed Ctrl C to copy the small script. Now I'm going back to the EC2 console and I'm pasting the script here. This script is basically going to download the Pokemon application and start it. And it will be executed because it starts with command bank /bin sh. And this is being understood by Amazon Linux as a script that needs to be run the first time that a virtual machine is created using this launch configuration. We are going to assign we do not need a public IP address to these instances, but we are going to assign it because in case you have any problem, you will be able to troubleshoot it in more easily, just connecting to those IP after you open the port 22 in the security groups. This can this can be improved from the security point of view, but we are not going to do that in this tutorial to keep things simple. After that, we add storage. 8 gigabytes is enough to store our information, and we are going to select the security group, the firewall of the application servers. We have already created it. It is here. We choose it. Port 8080 is open for the load balancer. So we are almost ready to go. Yes, I don't care too much about port 22 right now. And we have created a launch configuration. I just need to set create, and if we do not have a key pair and we want to connect to those instances because we are just learning, maybe you want to troubleshoot them in case you have any problem, you need to have a key pair. I'm creating one. Let's say this is the key pair for the high availability architecture on Oregon, and I want to download it. Done. In a production system, you do not need even to place a key pair, a public key inside those machines, because actually you do not connect to the application server nodes. You just want them to serve your traffic, and you troubleshoot every problem, probably using your logs. Now, yes, I just want to create the launch configuration, and we are already in the create autoscaling group workflow. So we have our launch configuration, Pokemon launch configuration, and we are going to start an autoscaling group named Pokemon autoscaling group, ASG. We are going to start with 2 instances. Remember, we are using 2 different subnets, and we want to place at least 1 resource on each subnet to be sure that we have high availability through different buildings, through different availability zones. We set the Pokemon VPC network, and we add both subnets, both public subnets, to the VPC. Again, remember, this is not the best option to deploy it in a real scenario, because there is no need to put those machines in a public subnet. We could create private ones with a NAT gateway to provide connectivity to them. And in that way, we would reduce the exposed surface of our system. We should not forget to click on advanced details, because we are going to select Pokemon LV as the load balancer that will automatically register those instances. And here we are going to say to the autoscaling group that it should use the Elastic Load Balancer instead of its own health check. This is not always the best option, but we are not going to discuss it here. Just it will be interesting to know that if the load balancer fails to check the state of the application, not of the virtual machine, but the application, it will terminate that instance and create a new one. Hopefully, that will create a new virtual machine with a fresh deployment of the application that will replace the non-running previous one. And again, we are going to activate CloudWatch detail monitoring. Okay, on this tutorial we do not want to scale, so I will press next here and I will ignore this screen. We do not want to automatically grow or shrink the size of the autoscaling group by creating or destroying automatically new instances based, for example, in the load of the nodes. That is the content of another tutorial. And we do not want notifications because I'm totally sick of receiving emails telling me that a new virtual machine, a new EC2 instance, has been added to the autoscaling group. But for sure, we are going to configure the tags, starting by a name. This is the Pokemon autoscaling group. An opener, which is myself, and a project that it is the high availability architecture, if I remember it correctly from the previous screens. I just need to go to review, and this is the special moment in which we press the autoscaling group, the create autoscaling group button, and the autoscaling group will start, of course, with 0 instances, but we want to have 2 instances on it. So the autoscaling group is going to create 2 different virtual machines inside our VPC, one on each subnet. Let's see if it works. Okay, looks like we have created the autoscaling group without any problem. And now we can go to EC2 instances and the dashboard of the EC2 service, and we will see if we have got success creating the new instances. Let's wait for a few seconds, and here they are. Maybe if I have done something wrong in the configuration or in the user data, they are not going to be correctly initialized. But let's wait a few minutes to check it. I will pause the recording of the screencast and I will see you in just a few seconds. Good! Looks like it is working, and actually the instances have been correctly tagged by the security group, by the autoscaling group. Okay, let's see what is the content of the log of one of those instances. Get system log. And here we can check if we have been lucky enough to download. Yes, look like we have downloaded the application. And maybe, here it is, we have started it correctly. So I guess that if we go to the load balancers option here, section here, load balancers, and we took a look at the state of the instances registered on this load balancer instances, both instances and in service, perfect. So if we take the ALB DNS name and we open it on the screen on the browser, using the default port, the port 80. Remember, the load balancer is publishing the port 80 and forwarding the received traffic to the port 8080 of the virtual machines. Maybe, ta-chan, here it is. This is our application. This is actually one of the nodes of our applications. If we reload several times the same screen, you will see that as our application contains two different Pokemons on each server, sorry, one Pokemon on each server, if you reload several times the same address, the traffic is going to be forwarded to different nodes, so you will see different Pokemons on each one. Good. And also remember that if you want to work as a chaos monkey and you go to the EC2 instances here, you can terminate any of these instances. Terminate, yes, terminate. And the autoscaling group is going to detect this situation and automatically launch a new one in a question of seconds. We are losing basically right now 50% of our capacity, of our computing capacity, but in a few seconds you will see that a new instance is being created here. Let's give it a few more seconds. By the way, the old instance, of course, is not going to receive any new traffic from the load balancer once the health check is not passed. Let's reload it a few more times. Okay, and here it is. The new instance is going to be started and will be automatically registered in the load balancer. So we have recovered in a few minutes, we have recovered automatically our previous capacity. Okay, that's all. Thank you very much. Remember, you need to destroy the autoscaling group, or at least set 0 as it in the number of desired instances. I'm going to do that right now. And that will destroy the instances associated to it. Then you need to go to your load balancer and also remove that load balancer. Come on. Thank you very much. And if you want, you are not forced to do that, but you can clean up the rest of the resources, the VPC, by erasing the VPC. Let's see. Here it is, the VPC. And by destroying the VPC, you are going to delete all the related resources. Hello, console. This is going... Come on! It is so tedious to wait for the refreshing of the console. Okay, here it is, our VPC. We delete it, and you will automatically destroy all the related resources, including the root tables, the internet gateway, and subnets. Oh, and the security groups. Okay. We will need to wait a few seconds. I don't want to take you more time. So let's finish this tutorial here, and I will destroy it. Come on, last attempt. Yes. Yes, looks like it is working. Anyway, remember, you can reach me. The easier way is to use Twitter, Ciberado, and you can also write me using my email address. It has been a pleasure as always, and remember, enjoy